Hey, we're back, screaming through weeks like that. We're rolling into week 4, and we built classes, and we touched on a little bit of encapsulism because that is remember we had private instance variables or the private variables in our car class, things that we want to make private so that they're not out there to be changed without permission of the class, right? So we're gonna look at that a little bit more. We're gonna talk about what's considered a UML class diagram, Unified Modeling Language. You're going to see UML diagrams in your future quite a bit. Software developers all the time, engineers, of course, computer scientists, yes, software engineers. You're going to get into wireframes too, but we're just dealing with classes and how we can plan, right? Because our final capstone is going to have a lot of meat to it. It's going to be a lot, and if you just start writing without planning your UMLs, you're going to be lost. So we're going to introduce using UMLs later. We're going to introduce them today or tomorrow whenever you watch the video. Okay, let's go. Let's go. All right, object-oriented principles in Java, and we're going to focus on encapsulation. And what does encapsulation allow us to do? Understand the foundations of secure and modular code. That's all it is, right? So we need a foundation for secure code. We also need to have modular code. And the good thing about modular code is if you write a really solid class or an object like that, it can go with you in different projects all the time. We reuse code a lot in software development. So it's important to understand how can you protect your data when you're making these things so they can be reused in a better place. And your code is going to be more secure. Secure code helps you get a job. Oop. All right. So what is object-oriented principles? Well, what is encapsulation? We just talked about what encapsulation is. It provides a way to encapsulize or put things into a package and hide it from the user. That's an advantage of encapsulation. So I'll give you some examples of it. We'll show some best practices. We'll look at UML class diagrams. We'll show you encapsulation in UML class diagrams, and I'll summarize anything. If you guys have some questions, all you got to do is Discord or email me. So that's what we're going to do today. So object-oriented principles. Okay, there are 4 pillars of object-oriented principles. Encapsulation, which is what we're going to do today, inheritance, abstraction, and polymorphism. I typed them backwards. But these are the 4 pillars, and they can go any way we want. Today we're going to talk about encapsulation, and then we're going to do abstraction, and then inheritance, and then polymorphism. So today is one of the pillars of object-oriented programming. It doesn't matter what language, C++, C#, Java, Python, any object-oriented programming language, these are the 4 pillars. So as a parrot, it's based on a concept of objects, and we talked about what objects are, which can contain data and methods that operate on that data. So we build something, an object, with what it is. If I want to build a mug, a coffee cup, right? We can build it in code, and we can say what it is. Well, it has state, right? What's it made of? How much volume does it contain? Does it have a handle? All these sort of things, right? And that's the state. That's what makes up my mug. And then I have behaviors. And a mug has some behaviors, right? Is it full? Is it empty? How much volume is left in it? Is it broken? Is it turned upright to pour into? All these things can affect me being able to put coffee in my mug. But I don't want the mug. I want to make sure that the mug is empty before I fill it, right? So that's the encapsulation, right? So my is full, if it's on, I can't put more liquid into it because it'll spill. So I turn off that ability to use the mug, right? And if it's empty, I can't drink from it because, well, it's empty. All right, not the greatest example, but that's what I got. All right, so it is bundling the data or the variables and methods that operate on data in a single unit, our class. The key feature is it protects the internal state of the object, and it exposes functionality through controlling access getters and setters. We talked about that last week. So understanding why we have getters and setters is really what we're doing here, right? Because we have encapsulation, and we bundle our data, and we put it in a class. So now our class has state. what makes it up. And then we want to control that state through getters and setters. We can print out stuff, and then we can allow changes to the state that will affect the behavior. And those are our methods. So let's look at a car, because we did a car last week. So we have a car. Speed, fuel level, engine status. And we have methods: accelerate, brake, and refuel. Encapsulation ensures you control the car via its interfaces or its methods rather than directly manipulating the engine. So we have a car, and we have speed, fuel level, and engine status. Okay? We accelerate, which changes speed. We brake, also changes speed. We refuel, changes fuel level. So we have to be in a specific area for us to do that. We don't want to give direct access to those variables. We want to control access to those variables. And those variables, speed, fuel level, and engine status, would be private. So, advantages: data protection, prevents unauthorized access, improves maintenance, changes in implementation don't affect the external code. It enforces separation, the separations of concerns. And encapsulated classes are really flexible and easy to reuse. We can make methods private too, so they're only in the class and only the class can call them. And that's pretty cool. So let's look at a bank account, because now bank accounts, this is important, right? You don't want people having access to your money, so you got to be in control of how your money is changed. So here we go. I have bank account. It's a class called bank account. We can see that right here. Beep. Class, public, class, bank account. Now, encapsulated account holder, because it's private, and encapsulated balance, because it's private. Okay? And then what do I have? I have my constructor. It's public, name of the class, and this is parameterized. So we're passing in the account holder and the initial balance. Now my account holder is going into the class's account holder, and my initial balance is going into balance. Pretty simple, because we did that last week, right? So now my constructor is working. Now I'm going to go to my getters. See, the getter only returns account holder. There's no way to change the value of the account holder. And then my balance, because that's a getter, that returns balance. So my balance doesn't change. It just shows me my balance. I can't go to get balance and say, hey, give me a $5 million. It won't do it, because one, it's not parameterized, and two, the getter only gets it. So if you don't have 5 million, you can't have it. But deposit, right? Deposit allows me to put money into my account. So if I say, if I create an account called My Money, I can say mymoney.deposit, and then I can deposit my money. I can say deposit $1 million. And then if my amount is greater than 0, then my balance becomes that amount. Here's the thing. You're like, well, now you can just put in whatever you want to. True, but you could have little things on here that don't allow that. Because in this method, this just has one check. You can't put in a negative amount because it's a deposit. So you can't put in a negative amount. But you can do a check here, like if deposit over 10,000, see banker, right? And then don't put the money in until you get approval for it. So you can't put that money in. You could even do like if you can have a counter in here, and every time they deposit, the counter goes up. So if a deposit account is over 3, see banker. So you just can't keep putting money in, right? So things like that. Say, oh, I can only put 10,000 in. I'll just put 1,000 in a million times. Well, you can't, because it stops at 3. So you have complete control over that variable, over your balance. Now, if I withdraw, I know I can't put a negative money in for deposit. But if I try and withdraw money, look, if amount is greater than 0 and amount is less than or equal to balance. Okay, so if I'm going to take money out, it has to be greater than 0, right? So I'm taking money greater than 0, but I can't take it out if your amount is less than your balance. So if I only have $100 and you try and take 200, it will not allow me to take the money out. That is protecting the data of your bank account. I hope that makes sense, because it does to me. We'll do it and we'll look at it. It's cool. So our access modifiers, we have public, private, protected, and default, and we talked about these. We are not going to use protected and default in this class probably. They're good, but you use them for different things, and we're just starting, so we don't need to muddy the waters. We're going to stay with public and private. And we know what public does, it's accessible from everywhere, and private is accessible inside the class. So if I make private balance, class bank account, private integer balance, or private double balance, only the class can change that balance, and that's done with the setter. Woo-hoo. All right, encapsulation process. Declare variables as private. Protect getters and setters, then provide getters and setters method. And that's what we did right here, right? If balance is greater, they're equal to 0, then the balance equals, this balance equals balance. So we could set balance. And we could make this much more strict if we want to. We could check the balance against a lot of different things and then either approve it or not approve the change of the balance. So one good thing about encapsulating, and you're like, it really doesn't matter. It kind of does, because you want to do more than just this class, right? You want to get into the industry and do something great. Well, you need to know this is an important part. This is one of those things that you're like, okay, I know how to protect the data, because sensitive data is hidden. You get your interview questions, you get past your lead code things and your efficiency questions, and they start asking you questions about data hiding and sensitivity and secure coding. This is the start of it. Validation ensures valid data through the controlled access. That's the setter. You can write really good methods. And when somebody passes value to those methods, you have a way to check the validity of that value before you add it to whatever variable the class is. And changes implementation without affecting the user of the class. That's the flexibility of these things. And the ability to write solid methods with private instance variables. Okay? So online shopping cart, right? Let's look at this. Let's example a use case. Online shopping cart. Our data is items, quantity, and total price. Our methods are add item, remove item, and then checkout. These methods control these variables. Okay, so that's encapsulation. We'll do a whole coding example of encapsulation. It's an important, it's really important to know the concept. It's really easy to put into place. You did it with your car class. If you did your car class correctly, you erased your cars. You had private instance variables or private things that made up the car, and we changed the speed with a setter. We did it already. We're going to expand on it this week, and not as much starter code this week. You'll be fine. All right, let's talk about these things, which is the unified modeling language. And this how we look at things in a visual aspect. How do we write our code? What do we do? How do we plan our code before we write it? So if I'm a software developer, when I was a software developer, they would give us these diagrams. And they'd be like, hey, this is how we kind of drew it up in our design part, and we need you guys to implement this. Because they wouldn't just come in and say, I want you to build an application that does this, this, and this. Sometimes they did. And we'd be like, well, okay, go back to planning. Go give us something to do. And then they would come back with, hey, we want this application, and these are kind of how we want it to go together. Sometimes we as the software dev people would go in those meetings. Sometimes not. All right? So let's look at a UML. There's key elements. We have classes, the name of the class, that's a rectangle. We have attributes or the fields, and the methods are the actions. So attributes, I like the keyword instance variables. UML uses attributes. So let's look at that. They're not complicated. So a basic UML diagram of the bank account, right? What we just did. Negative marks private. So here's my class, name of my class. What makes up the class, and what methods are in the class. Now you could hand me this, or I could hand you this, and you could write this. We could do an assignment where I just give you a UML and say, implement this class, which I might do. We might do that. That would be kind of cool. We've done it before, not us, but I've done it with classes before. It works out pretty well. So you would just say, okay, public class bank account, and then you'd say private string account holder, private double balance, then write a constructor, public bank account, string account balance, comma, double balance, and then this dot account holder equals blah, blah, blah. And then underneath that, you would say public get account holder, that's a getter, that's just going to return the account holder string, get balance, return balance, deposit, and withdraw. We talked about those. Those are our setters. So we have getters and setters, and the setters are responsible for being able to make changes to these. Okay? But initially they're private. So what do we have? Private is denoted by the minus sign, and public is a plus sign, and we're probably not going to do any protected. But if you're looking online, you may see the hashtag or the pound symbol or the real name for that, orthoscope, but that's not fun to say. So you're just going to see minuses and pluses, and minuses are private, pluses are public. Let's look at this again. If we did our car, right? We have engine status is Boolean, and notice that the name of the class is car. Private, private, public, public, public. These control the engine status, stop engine, and this controls fuel. Private, public. Variables or state, methods or behaviors. You could write this car class right now. I say, hey, go write the car class. You'd be like, all done. And you'd be like, hey, I did it. And then you'd be like, I want my money. Oh, I don't have any. Common mistakes are exposing fields directly, not validating input with setter methods, and overcomplicating simple classes. Sometimes if I'm like, hey, make a dice class is just a dice class. Don't make it anything more than it is. It's silly to have a dice class because it's just random numbers of 6, and you can control that with the thing. But anyways, these are the common mistakes. And a lot of common mistakes is number 1 right here. So exposing fields directly, this is what we look for when we are looking to break into your software and find vulnerabilities. So if I'm doing a stress test or a test on your software, I am looking for ways that I can expose the state of your object without a setter. Or I'm looking for a really bad setter method, and I just do it. If you don't validate the input in the setter method, then that's easy for me to make your software insecure. Not insecure like I'm taking your bad software. Oh, I'm so insecure. Not that, but like, hey, this is not secure code. Okay? And then if you overcomplicate a simple class, it's just inefficient. Nobody likes that. Best practice, keep your fields private. Whenever you, starting now, until you're told by another instructor, make sure your instance variables are private. You can always make a method to change them. Okay? Provide only necessary getters and setters. Use final for immutable data. Okay, and that just means do not make sure that, like, let's say you're doing it, we'll go back to banking. And it's like a constant in C++. You have dime, double dime. You can use float because it's less. Float dime. Dime is 10 cents, 0.10. That can't change. If you don't make dime final, meaning a constant that it can't be changed through the program, I might be able to go into your code or into your program while your program's running, change the value of the dime to $10,000 and then deposit 40 dimes. That's a lot of money. So if it's something that's not supposed to change, make it final. And then I'm not really big on comments. I like comments. Comments are important. Mostly I like when you put your name in your code. But do comment your methods for clarity. Okay, I don't need a paragraph on it. Just be like, this method takes care of the engine. So we have abstraction, and that's coming up next. We are doing encapsulation now versus abstraction. So encapsulation focuses on hiding the eternal state of the object, and that's what we have now. Okay? Abstraction focuses on hiding the implementation details while showing essential features. So one of the other pillars is called abstraction. We're dealing with encapsulation now, but then we're going to start dealing with abstraction. It focuses on hiding implementation details when showing essential features. I like to use microwave for abstraction. The abstraction is, hey, I don't know how this works. I'm just glad it does. So, summary of encapsulation: protects data through private fields or private integers and controlled access through setters. It does improve code quality by ensuring modularity and reusability. It enhances security by hiding implementation details. Like, hey, how come I can't take money out, $200 out, when I only have $100 in my account? It's letting me type 200. Well, doesn't work that way. UML, you need to visualize your designs following encapsulation principles in your diagrams. Let's say we're doing our Final Fantasy game, right? You're going to build hero, negative, 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 method, 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 right? And then you're going to have an arena, hero goes into the arena, so negative hero, and then we're in the arena, and then your hero will go to a shop. So if you draw these out, you'll kind of know and exactly how you need to code it. You code each object separately, and then you make them work together, and then they fight. Oh, and then you got to have a villain. And the bad guy, can also be a clone of your hero, but you'll be fine with another class villain. And then you'll probably make an array or an array list of villains, because you're gonna have a lot of fights, and that's gonna go inside the arena also. Because that's where they're gonna fight. They're gonna meet in the arena and do their battle. And you got to decide what methods are in the arena. Is a fight method here? Do they each have a fight method? Does the fight method go here? The shop just has stuff for the hero to buy in case he wins and gets money. You can go back and buy stuff for the shop and come back, help and everything. Villains, once they're inside your array list, and once you kill off villain 0, you're going to move to villain 1. Pretty cool. I'm excited for you guys to pull that off. You'll get there. So, practice examples. Let's design a UML class diagram for student and dorm system with encapsulation fields for name, major, and hometown. Okay, so this is going to kind of be a preview of what we would do with villain or hero and arena. But instead of having arena, we're going to have a dorm. Instead of having hero, we're going to have student, because you're all my heroes. And let's take a look at my diagram for this. Okay, this is what we have. Well, I have 2 classes. I have one called dorms, and I have another called student. Okay, I like that. In my dorms, I'm going to have a private name, and that's going to be from the student. What is my data type? This is my variable name, and this is my data type. So what is my data type? My data type is students. Should be students. My data type is students, because students go to the dorm. Because my dorm can hold many students. 1 to many. Okay? Many students. And then I have my string, which is going to be the major. What are you majoring in? And then I have rooms. And what are rooms? Rooms are an array list of students. So rooms are an array list of students. That's pretty cool. This is my constructor. Notice it's public. These should be S's. This is default constructor. This is my parameterized constructor, string, string, string. And it should be string, string array list, but we'll get to that. And then this is my student, and it's a getter and a setter. So I can add students. So what do? I put a student in, it goes to set student goes into the dorm. So every time I want to add a student to the dorm, to a room in the dorm room, I set student. If I need to get students, I can get students via the variable number, or the index of the array list. Here's my student class. Name is going to be a string, and hometown is a string. Default constructor, parameterized constructor, and then a getter. Student doesn't make many changes. Once we get their name and hometown, we throw them into the thing, and then they're ready to go. But let's make this a little bit better. So we need to make the dorm more. Right now it's kind of blah, blah, blah. Right? So what do? Well, we should let the students pick a major. The dorm constructor will use methods, so you don't need to parameterize constructor on that. So now we have students able to pick, sorry, student to do. So now we have dorms is going to have our students and then our rooms. Constructor, and then get students and set students. That's what it does. It gets students and then it adds students to the array list, and then it gets set students. Here we have string, string, string. These are all private. Constructor, a void show, which is my getter, and then I have a setter, which is also void. Setter is string, string, string. Setter lets me do name, major, and hometown. So setter lets me do that. That's pretty cool. All right. Well, we're going to implement the diagram for students, and then we're going to talk about more encapsulations and things like that. So next slide, I'm going to go over and I'm going to write some code, and then we'll have a little homework helper. And you guys are awesome. We're into week 4. We got plenty of weeks left. We're moving at a pretty good pace, but that's okay because we've got a lot to do. And this is what we're supposed to be doing. We're supposed to work hard, but I'll help you every way I can. All right. Next slide will be, I'm going to implement our student and dorms. I'll put some students in the dorm, and then we'll have some fun with that. Okay. Bye. Hey, here we are, and we're gonna go over kind of what we talked about. We're gonna make a student class, and we're also gonna make a dorm class, and the dorm is gonna control the students. So we have an object interacting with another object, and it'll kind of fill out our encapsulation data, keeping data safe, and doing things like that. Notice I'm just in Java right now. I got rid of my my hello world, so I'm all ready to go. I can run, compile, do whatever I want. Again, one thing I don't think some of us are doing that I really, really would need you to do is you're not typing these examples out and seeing how they go. You're kind of just watching them. You read the code. Maybe you take it from the text. Maybe you work with it. Maybe you don't. It's important. Like if we were in person, it would be important that you do these exercises. So do these exercises and you'll be all set. All right. So let's get out of our main and let's make a student class. And we're just going to make a super simple student class, okay? So let's go up here and we're going to do a new file. And it's going to be called student in Java. Okay, student.java. And brings us to our student class. And our student class is really simple. Public class student, right? Everything inside of these brackets belongs to that public class student. So we're going to have two things that make up our student. Private name, private string name, duh. And then string major. That's going to be our student. We could throw, like we did earlier, we could throw a GPA in there, but we're not going to. We're just going to do that. And let's have a default constructor, public. And then we're not passing anything in because it's that. Dot name equals unknown. And then dot major is undecided. So when we initialize a student without a parameter, it's just going to be an unknown name and undecided major. Now we're going to have a parameterized And then that is going to be string name and string major. And then that's going to be, we're going to pass those in, and it's going to build our student's name and major. Now you can expand on your student if you want to. That's all good. We're just going to go simple. And then now we have a constructor, and we're just going to do a little getter. And it's going to return a string because we're going to get a string, and the name of it is getName. So what does this do? This just gets the name of our student. And then we're just going to do return, and then we're going to do a string literal name. Get back here. Major. Format a little bit. Beep, beep. And name and major. Okay, so this is just going to return a name and major. So when we say, hey, get student, that's easy. We got nothing going on but this. This is really, really simple. This is our student class. We can make it bigger. We can make it smaller. Right now, we're going to check it. Space. Make sure you space that. You guys probably caught that. And then default. This is just our all right. Sometimes it autocorrects for me, and that's not good. So default.getStudent, get student. I might have even spelled something correctly the first time. So here we go. We have a default student. It should just print out unknown. Default's a keyword. Default is a keyword. Don't use default. Method is get student. Leo, get student. Oh, get name. Jeez. Rough start. Get name. There we go. All right. And that's our unknown and undecided. So if we want to, we can actually make Leo the dog, and Leo is going into computer science. We'll just do CS. All right. All right. Everything works. That's Leo the dog. His major is computer science. Sorry about those earlier fat fingers, but that's how it goes. All right. Student works. Bravo. Student is going to have to go inside of a dorm. Dorm.java. All right. Now we have a dorm. So we're going to be using help if I'm typing, an array list. So let's start there. Public class, dorm, bracket. We have a class, everything inside of those brackets belongs to that dorm. Now we're going to use the student class that we did because it's just a data type, like an integer or a string or a double or anything. It is just a data type. So we can use that, but we want to make sure it's private. We're going to do add student, not add student. Add student. All right. Private student, add student. Now, can we do that? Sure, of course we can, because it's just a data type. We can also do
Because what is we going to do? We're going to have dorm rooms, but that's going to be an array list. And what is the array list going to hold? The array list is going to hold student, right? Now I have an array list of students. We kind of did this with our dice thing, but now we're storing objects in it, and that's kind of cool. So now we got object student is going to be stored inside of the dorms. Okay, so let's get a default constructor. And that's just going to be our generic student, and that's going to be add student. Because we have a student object already that we're doing. New. Okay, if we wanted to test things, we can just add generic students, right? But we are going to, that's good enough. We're going to use a setter. Let's build a setter. Instead of a new constructor, let's just do a setter that adds students to the student array. So what we'll do is we'll build the dorm, and then we'll add students to the dorm. So now we're just going to build a setter that adds to the students. So it's going to be void, public void, and that's just going to be a set student. And we are going to pass in name, major. Because those are the two things we need to build a student. So this allows us to add student. So what do? Add student equals, make an equal sign, equals new Now, why is this? This looks just like we did over in the main. Well, it's because we can do that. We can do things. We can build in other classes. Classes, object-oriented programming means objects have to interact. That's the beauty of it. We can build objects and all these objects can interact. So when you're becoming a software developer, you have to understand, hey, I can build an object and it can be a part of another object, or an object can interact with another object, and that makes your application really cool. So now we have a student called add student because we already initialized the student up here. So now we have a student called add student. Well, we have a variable called dorm rooms. Not yet. Now we have a variable called dorm rooms that holds on to our students. So we're just going to go dorm rooms dot add, and what are we adding? We're adding the object we just created. Every time we call set student, we're just adding into the dorm room. So now the dorm room is doing its thing. And that itself is kind of cool. I think that's kind of cool, right? So we're going to want to know how many students we've added. So now we're going to do another getter. And that's just going to get the size of our dorm rooms, or how many students we have populated. And that's going to return, because we have an integer, so we need to do an integer, and we know that we can do dorm rooms, and since it's a vector, we can call the size method, and we can make the size, and that'll give us all of them, but that might show an index out of bounds error, so we're just going to go size minus 1. So if we just did size, and let's say we put in 4 students, we would have 0 through 3. So here, when we do our size, we're just going to say 0 through, well, let's just get our regular size. We'll deal with that minus 1 later. So that's a regular size. That might just be goofy. Now, all we're going to do is get our student. So now we can populate our dorm room, but not only can we populate it, let's say we put 5 students in there, we can go ahead and say, hey, who do you want to meet? Who do you want to see in room 0? Or room 1, or room 2, room 3, room 4. We will use our minus 1 technique on this. So let's do a getter. We got a setter for size, a setter to populate the dorm rooms with students, and now we're going to get a getter to just get students. And we'll just do it void, I guess. No sense in returning. We can return a student, but we'll just keep everything where we need to be. we're going to pass in a number, right? So what we do is we're going to pass in an index. The index is going to go into the array list. The array list is going to fill up add student, and we're going to print add student get name. And that's kind of cool. So let's do that really quick. So let's say add student is going to equal dorm rooms dot get at room. So I pass in a 0. It takes the student, it index 0, and it puts it into add student. And now that I have that, I can go system, print line, add student dot get name. Get name. And that'll show me what's in the index that I passed in. So the dorm's doing a lot of heavy lifting. The dorm we're going to build the dorm, and then we're going to say, hey, we need to add some students, and then we'll start adding students, and then we'll say, hey, our students are there. Maybe you want to see who's in whatever room you'd like to. And then we're like, okay, I'll take a shot at it. So let's go to our main and make all this stuff happen. And our main's going to be a little busier than I thought. Later we start building our menus and stuff in another class. So we're going to import java.util.star. Just bring me everyone. Now we're not going to build students here. The dorm is going to build our students, right? So let's why would I want to make a connection with Zoom? All right. So let's go ahead and do this. We're going to build, let's do our scanner. SC equals new scanner. Just trying to, Zoom is trying to open up. That's weird. All right, sorry, but I'm getting this weird error on my system. Scanner SC, new scanner, and system in. So we're creating, again, we're using the new keyword to create an object from the scanner class called SC, and that gives us the ability to get user input. Name and major. We're going to need name and major because we're going to ask, hey, who do you want to be in the room? Now we're going to do, we're going to ask the user after they're done to be like, hey, do you want to see anybody in a certain room? So now we're just going to make a dorm object. So dorm, cactus, no, just a default constructor. Dorm cactus equals new dorm. That's it. It's created. Now we can do something really cool. We can enter. Let's do three. Let's enter 3 users. Let's enter 3 people. Will you just get off my case, Zoom? I need to go to Task Manager really quick. Finish this. Where's Zoom? Look at this. We got everything running today. Why are you there? There you go. All right. It won't pop up anymore. Sorry about that. So dorm cactus equals new dorm. And that's great because we've created that. We're going to enter three users. And we'll just do it this way. You can enter as many people as you want. You just change your, you don't even know how to do that. You can do whatever you want to do. So now we're going to do system.out.println. And then name equals sc dot next line. Function, don't forget that. Let's just double up. All right, we're getting name and major, but with user input. And then all we need to do is say cactus, right? Get student or set student. And we're going to pass in name, and we're going to pass in major. Okay, this shouldn't confuse you too much. It's pretty cool how it works, right? We have our dorm class, and dorm is managing the students and storing students into a student array called dorm rooms. So we have 100 students. We can just keep adding. We want to get rid of some, we get rid of them. They graduate, they pop out. Our students' class is relatively remedial. Here, I'm doing my scanner. I have my name and major. Room is 0, and then I say, hey, cactus equals new dorm. That's great. For I is 3 times. It comes through, and each time it creates a brand new student. Now, what's happening is the student is actually stored. I wish I had a way to draw this. So you take our indexes. The first student is going to be put in index 0, then index 1, index 2, index 3, index 4. That's the name of the student, right? That's where we find the student. So instead of saying like student Leo equals new student, we're just saying, hey, dorm, just take Leo and put him into 0. And if I need Leo, I'll go to his room to get him. That's all that's doing there. So that's pretty cool. And if we want to see our guys, we can ask, you know, hey, can you give us this? And it's like, sure, I'll give you whatever you need. But we'll just print them out for right now. Darn it. I was hoping it would populate for me. Sometimes it does, sometimes it doesn't. All right, my Eclipse does. You're like, good for you and your Eclipse. So let's use some of our information that we have here. Here's something we can do. Because this returned a value, right? This returned the size of our array list. So if we put in, like, if we made this 10, we don't have to change it. And then we're just going to say I++. And what do? Well, we do really simple. Cactus dot get student at index I. Because remember, get student is taking an integer, right? Dorm, get student takes in an integer. I is going to be an integer. So I put 3 in there. It's just going to go in there. It's going to go from 0, 1, 2, and 3 and print them all out. Maybe. Let's see how this works. Cross your fingers. I've been typing with my eyes closed and pop-ups from Zoom meeting that I had earlier that wouldn't go away. Oh, it's connecting to the server. I might have dropped my... Come on, ain't nobody got time for this. When that happens, guys, save. Or try and save. Maybe beautiful. No, come on, run. Whoops. No, if I refresh, I will go away. Boy, that's an awful thing. Well, here's what we're going to need to do. We're going to need to refresh, and I'll come back and retype. I'll retype all this. And then I'll stop the video, I'll retype it all, and then we'll get it to run. All right, hold on. Okay, I got to clean some stuff up. I just blew through my internet connection, so but I did get it retyped up, and we're ready to go. So let's run this and see how it goes, and then we'll talk through it, and I'll post this code for you in the week, whatever we're in, week 4. So it says enter student name, and that's where I am right here in my loop. So Mike. And I'm going to be an art history major. Leo the dog. Leo the dog is going into computer science. And then we're going to go Tom. Tom Thumb is going to drop out. Tom Thumb is going to be a dropout. And then we did it, and now we're going to see our three things. And what did it do? It name Mike, major art history. Name Leo the dog, major computer science. Name Tom Thumb, major. Well, he dropped out. Poor Leo. Anyways, or Tom Thumb. So we have we made students, and what do? Our dorm was in charge of populating our student array list. And that is pretty cool stuff. So that's about it. I'll tie this stuff up. Please watch Homework Helper, and you guys are super awesome. Talk to you soon. Bye.